Okay, in this video, I'm going to discuss the reasoning behind the Python function bin2decFixed. So we have a binary number that represents a fixed point decimal number. Now, in the code, we specify the number of bits that are integer bits, and the number of bits that are fractional bits. So in the code, you'll input this string of ones and zeros as an array, and you'll also input to the function the number of integer bits and the number of fractional bits. Right. We want to make use of our bin2decInt that we had before. So what we can do is just first treat us as an integer and convert all the bits together. So I can first take bin2decInt of this whole number, so that would be 1, 0, 1, 1, 0, 0, 1, 1. Okay, and this has the number of bits here is nint plus nfrac, because I'm putting all the bits together. Okay, now when I convert this, this is going to convert to a decimal integer. Right, but I don't want an integer, I want a fixed point number. So what's the difference between this number and this number? Well, the key is the fact that when you shift the decimal point in binary, that's the same thing as multiplying or dividing by 2. Same thing as when you shift the decimal point in decimals. If I have, for instance, if I have 2.9 and I shift the decimal point over 1, then that's 10 times. I've shifted the decimal point over 10 times. Now, if I shift the point in binary, that's multiplying by 2. So I want to shift the decimal point. Now, you can think of this integer number as having the decimal point at the end. So I want to shift the decimal point 4 places to the right. And 4 corresponds to nfrac, okay? So I want to shift the decimal point nfrac places to the left. Now, does this correspond to multiplying or dividing? Well, you have to think, is this integer bigger or smaller than this fixed point number? And you have to think the integer number is bigger. Why? Because the decimal point is farther over here. Every time, just think about it, when you shift a decimal point with decimal numbers to the left, you're dividing by 10. So if I'm shifting the decimal point nfrac places to the right, that means that's the same thing as dividing by 2 to the nfrac. Okay. So I can summarize my algorithm as follows. Oops, it's not working very well. Summarize. Okay, so we do the integer conversion. So I guess it's bin2decInt of the entire binary string and then the second step is simply going to be divide by 2 to the nfrac. Okay, and that's going to get me my binary to decimal fixed point conversion. All right, now to go the other way, decFixed to bin. Right. Now up here we saw that we needed to specify the number of integer and fractional bits in the binary in order to make sense of the conversion. So when we input the binary, we input a binary list and also, I think it's actually an array, a binary array, and then we also specify the number of integer bits and number of fractional bits as our. So to go the other way, we're also going to specify the number of integer and fractional bits. One reason for doing this is that decimal number may have a repeating decimal binary as the fractional part. So we need to cut off the fractional part. We can only specify nfrac fractional bits. And we also may have a fixed length for the integer bits, so we want to specify the number of integer bits as well. So what we should do here is basically undo the other way. Now, the other way, the second step we did was divide by nfrac. So if we're going to go the opposite direction, we should first multiply the decimal number by nfrac. So step 1 is multiply decimal number by to the nfrac. So that undoes the second step in the binary to decimal conversion, right? And then you want to take the integer part of that. You want to take the integer part. Okay. Then what do? Well, then you have the decimal corresponding to the integer that we had up here. Okay. So we just want to convert the integer back to decimal. So you just perform. Okay. It should be a 2. So you just perform. So this is going to be dec int to bin on the result of 1. Okay. All right, so that's going to get me, well, it gives me all my binary bits. Okay. And then all I need to do is, I know here, I specified the number of integer bits and the number of fractional bits, so I just need to maintain that. So I have an int and nfrac. Oops, sorry, nfrac. We're already given. Okay. So really I'm done. I have found my binary digits, my binary bits, and as part of the inputs I have the nint and the nfrac. So my decimal fixed point to binary conversion is accomplished.